Hi everyone, hope you're well. This is a walkthrough of Access using a textbook store example. This is through a desktop version of Access where I've opened up the database. If you want to use Apporto, then I believe the web address is apporto, apporto.uncc.edu. You can open that up. Access is one of the software you have access to through the browser. You don't need, if you have Apple, a Mac, then you can use Access there. And it's basically a Windows environment that it creates for you, and so you can use it virtually through the cloud. The only catch there is you have to upload any files to the cloud that you want to use, because it's basically like a temporary environment, a virtual environment that you get to create, and then you would download any files possibly as well. So, but this is using a desktop version of Access, which you can, I believe, get access to through the UNCC software site if you have Windows. Alright, so this is a simple little database, and Access is a database management software. And so some features here. On this left pane you have the different objects, and so you have tables. You can also have queries. I've created some queries here, and you can click on each of these and take a look. So, and this is a very simple database. So you've got a customer table that has a handful of customers. You have a product table that basically lists out the products, and like I said, this is a textbook store, and so there's different textbooks that are included in here. ISBN, title, author, year, etc. You have a sales table that basically keeps track of the sales, and notice this is only for a short period in December of a given year. And so you also have a salesperson table that keeps track of individuals that are ringing up the sales. Could be a cashier table, right? You got different names for it. And then you have a sales detail table, and so this detail table is what allows the sales table to have more than one product that's being sold, right? Because if we look at the sales here, sales table, we have a sales date, and notice we have a unique identifier, right? Every table is going to have a unique identifier. Oftentimes it's called ID. Sometimes it has another name, product ID. This could be sales ID. Salesperson can be salesperson ID. Every table needs to have a primary key, which is the name for the unique identifier, because it uniquely identifies the row. Because one thing about databases is they don't allow, or at least they're meant to be designed to not allow duplicate records. Whereas that's something that Excel doesn't necessarily have, right? Excel, you can have duplicates all day long. You can even have the same name in fields, right? You can have 5 fields named the same thing in Excel. That would not be allowed in Access in a database, because a database, every column represents a unique data element or data attribute, and so you can't have the same name being used for multiple attributes or multiple columns. So anyway, coming back to this, the fact that in the sales table we have we have sales date here, we have a salesperson ID, and this just references the ID that's in the salesperson table, right? And so we'll look in a minute at some relationships. You have a customer ID, which just references the customers in the customer table. And this is just a more efficient way by using the customer ID in the sales table to reference that customer, right? It's better than putting a customer name, because oftentimes, depending on how large the firm is, you can easily have names that are not unique, and so we have their customer number instead. We have payment type here. We have some other potential details. And we could have payment amount and some other things, but this is just the sales piece, and so don't worry too much about these that not being filled out. This is really just to kind of show you some possible things that could be in the table. And again, kind of the key pieces of the table, you have rows that represent unique items, and then you have the columns that represent the different data elements that are available for each of those items. Okay, now if we look, one of the nice things about Access is if you go to Database Tools and go to Relationships, you can actually see, and you can really specify, because this is something I had to specify, the relationships between the tables. And so this is one of the big advantages of Access over Excel, even though there are some potential add-ins that are trying to make Excel more like a database management software. Access does this natively, right? This is kind of what it was designed for, whereas Excel was not designed to be a database, even though there are some things you can do that try to mimic a database. But one of the big advantages is instead of having sheets, which is what Excel has, right, we have tables. And so each of these tables are specified. This is basically the conceptual view of the database, where each table we have all the columns, right? So with the customer table, we have each of those columns, right, that we found in the customer table, right? Each of those columns becomes an element in this listing of the customer table. And it's just an easy way to reference a table without referencing the data. Okay, and so this conceptual view shows the relationships. And so when we think about this relationship between customer and sales, okay, so the way you think about it is, for a given customer, how many sales could you have? Could you have only one, or could you have more than one? And so if the answer is more than one, then you say you could have many sales, right? And that makes sense. For each customer, they could have multiple textbook transactions, right? But for a given sale, how many customers can you have? And obviously, you could have different business models where you could potentially have more than one customer. Like, let's say you have like a car purchase where you have multiple people listed on the title, right, or listed on the bill of sale. But for this simple example, there's only one customer that's allowed. So for a given sale, there's only one customer. And so you can imagine there being a 1 right here on this side, and a many, which is often represented either by an M or an infinity symbol. And so that's called a one-to-many relationship. So for a given customer, right, I could have potentially many sales. Okay, and so when I connect it, and I'll just go ahead and delete this relationship just to show you how to create one. So I'm basically going to take from the one side a customer. Notice I have customer ID here, and then in the sales table I also have customer ID. Well, in this table it's called a foreign key. Okay, and a foreign key is just an item that is a primary key somewhere else. And so even though these aren't named the same, one is named ID, one is named customer ID, these are essentially the same elements, right? And so to connect these, I drag the ID and I can drop it right on top of the customer ID. And notice when I do, I get this pop-up window, and I have the customer table ID is essentially the sales table customer ID. And that's how those two tables are related, because you have one data item that is placed in the other table. Okay, and so notice it even kind of guesses for me here down below the relationship is a one-to-many. Okay, as I can go ahead and create that, and now you see the one-to-many, or excuse me, you see the relationship between the two. And I've just already done the same thing for these other tables, and so that's why you see these relationship lines for each of these tables, is because I've already kind of dragged. Notice here, right, let's go between salesperson and sales. So for a given sale, I'm only going to have one salesperson. So imagine the one is over here. But for a given salesperson, they could be involved in multiple sales, right? So the many is on this side. And so again, that's, if you right click, oops, you have to right click directly on the line, click edit relationship, and you see that the ID from the salesperson table and the salesperson ID from the sales table are connected, and that relationship type is a one-to-many. Okay, and so we can see that has been defined. Now the trick here between a sales table and a product table, this is where things get a little bit hairier. And so if you think about for a given sale, and again this is selling textbooks, just think about how you've bought textbooks. For a given sales transaction, you might buy multiple textbooks, right? And so I have a many over here. But for a given textbook, it could be involved in multiple sales, right? Hopefully so, if you're the textbook store, right? You don't have a textbook that's just sold one time. It can be sold many times. So you also have a many over on this side. And so whenever you have a many-to-many relationship, the only way to solve that is to create a linking table that basically connects the two tables. And so the result of this connection between sales and product is this sales detail table. And so now, instead of having a many-to-many relationship, which you can't have as far as the database structure goes, now I have two one-to-many relationships. And so notice here I've got the sales ID. It shows up as a foreign key in the sales detail table. The same thing happens with the product ID. It shows up as a foreign key in the product table. Okay, and so this table allows this many-to-many relationship to be actually operationalized into two one-to-many relationships, right? So the sales ID to the detail table is a one-to-many, and then the product ID to the sales detail, so I can right-click it, is also a one-to-many. Okay, and so that's the structure you need. So how does that look? You can notice here, right, we got this primary key of sales ID. That's now a foreign key. Same thing for the product ID. That's a foreign key. And then we have a quantity. So the easier thing though, because we've defined these relationships, then when I open up the sales table, we have this little plus sign over here. And I can actually see now the detail that's associated with that sale. So I don't have to look at the sales detail table and say, okay, for sales ID 1, it has sold textbook ID number 2, right? And sales ID 1 is also sold textbook ID number 3. And so if we look here at sales ID 1, that's the one we actually want to pop open. What do we see? We see product 2 and product 3. In this case, only one of each has been sold. And so, but that's the detail that's associated with that sales transaction. Because you wouldn't be able to put product ID, right, into a sales table because it would have to have two values. And you can't have two values in one column. And so we have to solve that problem by having another table that keeps track of the detail of the sales transaction. Okay? And so that's how those are related. Those are the relationships. Again, this is what's called the conceptual view of the database. And it's a nice way to kind of see how the different tables are related. And this also helps you decide on what can you actually join together, right? I couldn't join salesperson with the product table directly, right? There's no direct relationship between those two tables, so I could not do a join between them. I would have to do a join to the sales table, then to the detail table, and then to the product table, right? So it'd be a multiple joins in order to be able to connect these two pieces of information. But I can, anytime you see a relationship, that means you can do a join between those tables, okay? And so if we want to look at doing a join, and actually first we can take a look at a query. That's actually a little bit of a complicated query. Let's not do that one. let's do sales by salesperson. Okay. And so in this case, it's kind of simplified. All I really am pulling out here, once you put a table in, then oftentimes it puts in the tables that it's connected to. Let's say I just want to look to see who is making sales, right? And so I don't need the detail table, I don't need the product table. All I really need is the sales table, and I need the salesperson table. Okay, and so this allows me to summarize the sales by grouping the sales by salesperson, and then counting up the number of sales. And so that's where this table came from. You have these 3 different salespeople, and how much sales they've had in the period. But probably a better thing to do is for us to try and create a query on our own. So let's create a query, and let's say we just want to pull from the product table and from the let's leave that one open. Let's say we want to so let's say we want to pull from the product table and the customer table and the sales table. So if you right click here, you can click on show table, and so you have this add tables column or panel on the right. So you can double click for customer, and let's say we want to pull out sales, and those are the only ones I care about. Okay, so you notice it already, once I add these 2 tables, it already remembers the relationship, again because we've already defined it over here. It recognizes this relationship between sales and customer, so I don't have to redefine it again. And so once I've set those 2 tables, then I can decide, okay, what do I want? And let's say we just want to know, let's look at sales, maybe the date, maybe look at the payment type, and then let's pull in the customer name, right? So we just want to get a sense of, we're a listing of sales that include the customer, and so all we need to do is include those items there. And notice what we need to do as well, we need to right click here, click on join properties, and this is where we can decide on what kind of join we want to do. Okay, and so I just created this little thing to try and help you understand the different kinds of join property or joins we can do. Okay, so if you remember back to statistics, there's a way we can represent 2 sets of data using what's called a Venn diagram, right, which is just circles. And so these circles have a piece that is, so they represent the extent to which the data overlaps, right? And so you can imagine one circle represents customers that are in the customer table, or records in the customer table. Another circle represents the sales transactions in the sales table, and there's an overlap between these 2. No, the reality is there should be almost perfect overlap in the sense of sales transactions should have customers, right, and customers should have sales transactions. But you can imagine for a given period, you may not have sales transactions from every customer, right? And so it's possible that we do have some areas that don't overlap. And so if we want to think about the different kind of joins we can do, then we can think about these 2 tables as one table is on the left, we'll call them the customers, and the sales transactions on the right in this case. And so if we want to consider the sales, joining the customer table to the sales table, then the left join would basically say, give me all of the customer table and give me any matches with the sales table. And in that case, we would get, let's see if I can do this here, we would get all of the customer table, right, but only the part of the sales table that matches. Okay, And so we would say that is the customer table left joined to the sales table, and the way we joined or connected them is that customer ID that we found in where they're connected in terms of the relationship. So if I was going to do that, then I would basically select this option 2, where it says include all records from the customer table and only those records from the sales table where the joined fields are equal. Okay, so let's take a look and see what does that look like if I run that. And so because it's a query, we can just look at the datasheet view, which just gives you the results of the query. And you can see each customer, even though it's not quite sorted that way, each customer has the relevant sales transactions that they're associated with, right? Now notice we have 7 records here, okay? We have 7 records. Let's see now if we switch this around. Let's go back to the query. But first, maybe let's save this. And so I'll call this customer left join sales. Okay. And I know it's kind of a long name, but I found it's better to be descriptive in the names as opposed to leaving lots of uncertainty about what you're actually doing. So if we come back to design here, and let's see if it'll let me, I might have to copy and paste it first. So let me create a copy, and we're going to alter it. And so now I want to do sales left, or we can even say customer right join sales. Okay. And so let's look at that, and we need to change the design. And here, let's go back to our PowerPoint. Here, if I want to do a right join, then, oops, let's see, I thought it was going to let me do my squiggle line. There we go. Right now, I'm taking all of the sales transaction table, but only matches of the customer table, right? That's what is going to be included. And again, we'd say that this is a customer right joined to the sales on customer ID. Again, that's what links the two tables together. That's why we can connect the data, because we have a common element. Now we could have easily flipped the order of the tables and put sales on the left and customer on the right, and said sales left joined to customer, and that's the same thing as this customer right joined to sales. So don't get too hung up on the left and right. Really, what really matters is you make sure you understand which one of these has all of the data from the table and only matches from the other, right? Because notice here, there's a possibility you have some customers that are not going to be included in this join. And so if we come back to access here, since we already set this up as a left join one way, we can change it very simply to be a right join by just choosing option 3, which again, make sure you understand the description is all the records from the sales the sales table. We're going to keep those, and then only those records from the customer table where customer ID equals the ID in customer, right? And so again, you could have easily switched which is left and which is right, but again, the key thing is which has all the records from that table versus only matches. So if we click OK there, we'll keep the same items in terms of elements, and then again, you can either click the datasheet view or the run. And notice here, we also have 7 transactions, but what do we have? We have one transaction as a missing customer, right? That we did not get, we have 8 transactions because we have one transaction that has a missing customer. And that's different than the left join, where we only had 7 transactions because we started with the customers and said, give me all of the transactions they have. But the right join says give me everything from sales, and then only matches from customer, and it turns out we have one sales transaction that doesn't have a customer. So notice these two, the way that you join produces different results, and that's important because the way that you do the joins determines what assertion you're trying to test, right? And so if you want to know, for example, actually knowing whether there are any sales transactions without a valid customer, right? That's a potentially helpful thing to know, right? Because it calls into question the validity of the transaction if you don't have a valid customer. Okay, and so that's a possible test to look at. But again, looking at the, there may be some other things you want to look at. In this case, doesn't quite mirror what we're going to have for the data analytics project, but you need to make sure you understand the direction that you're trying to join things in. And in this case, we don't have, for example, other steps in the accounting cycle, right? We just have the sales, which presumably we could imagine that to be the sales journal, right? And we don't have, for example, anything before it which would represent whether the sale was earned or not. And we don't have anything after in terms of like cash receipts. So this is kind of a simple example. But if we had something that represented an economic transaction, which would be earlier in the accounting cycle, then if we started with what was in the sales table and then tried to match to what was earlier, right, that is existence, because the sales journal represents what's recorded as revenue. Well, how do we test whether the revenue exists? How do we test whether the revenue is valid? Well, we go back earlier in the accounting cycle and look for evidence that it was a valid transaction. And so if we find evidence, then we feel comfortable that it was a valid transaction. Obviously, if we don't find the evidence, that's where the doubt comes in. But so that's one direction, right? So that would be a join where we start with sales table and look for matches with the earlier table. And then obviously we're looking for sales transactions that don't have a match, right, in that situation. We can go the other way where we start with an earlier piece of evidence that a transaction occurred and then check to see whether it was recorded, in this case going forward to the sales table. And if we do that, then that is checking on completeness. Did all of my economic transactions actually get recorded into an account, right? In this case, it'd be the sales account. And so I would start with that earlier table, do a left join with the sales, trying to keeping all of the earlier table and just matches with sales, and then looking to see are there any non-matches with that earlier table, and then those would be my exceptions. And again, that would be more on the completeness side, whereas if you start with sales and go backwards, it is existence. So this left and right join, or really kind of whether you keep all of the records from one table versus another, it gives you different results and they test different things. So that's important that you keep that in mind. Okay? And the other thing I wanted to kind of note here, if we go back to design view, you can always turn any of these into a table that is permanent. So if you click on make table, you can just create a name, right? Customer, right? Join sales. And then you could do other things with it. And so if you do that, then you have to click the run button. Oops, let me save this query. Now let's run it. Why would it delete it? Oh, I think I named it. I can't name it the same thing. That's the problem. So table. If you name it the same object name, it's going to write over it. That's why I was asking you to do that. So now that I've got that cleared up, it's telling me, okay, you're about to paste 8 rows into a new table. Do I want that? Yes, I do. And notice it puts that object up here. And now I've got a permanent table. And it to where if you go back and look at the design view, right, it gives you just items from a table if you're going to create your own table. It doesn't give you the query because, again, this is a permanent data set now. Okay, now if I wanted to sort this or filter, I click on that little drop down and say, well, I just want to focus on the items where there's not a a blank, basically a non-match, and then that filter again allows me to do that pretty easily, and then I can hone in on kind of the exception, right? And so the nice thing here is once you kind of do this filter, you can easily take a screenshot of this transaction, or let's say there's a handful of transactions, and then you can provide that as evidence in your in any report you might do for analytics, right? So hopefully that makes sense. I'm doing this without an audience, so I don't have any questions that are being asked. But hopefully this makes sense as far as at least some things you can do to walk you through. Let's say I want to take that, I can export that table to Excel really easily. Just right click on it, give it a name and a location. Right, you can do the formatting. You can open it after the export is complete, and then you can have that in Excel. Obviously this is a very simple table. There's just one item here, but you could potentially have more depending on what you're trying to do. Okay. The other thing I want to show you is possibly to save you a step for going to Excel. Let's say you had, not just one record, you had multiple records, and you wanted to put that to Excel to create some totals, subtotals, right? So in this case, we don't have an amount here, but let's say you want to do a count, right? You can do a count. If this was a dollar amount, you notice it only gives me the option to count it. Right? Same thing for here. It just gives me a count because it knows it's unique ID. It'd be tricky. I mean, average of a date doesn't make a lot of sense, but you could do min and maximum, right? That could be an interesting. You could do a min for one, and that you might be able to add a second. I'm trying to think if you can. That doesn't look like it. But you might be able to do a minimum or a maximum on this. You could do a sum. Let's say one of these was a payment amount. You could do a sum and total up the amount of sales, for example, that had a given exception, right? So that would be something you could do. That could potentially, let's just do that there. Let's get rid of that one. That'd be something you could do that would possibly save you from having to export it to Excel. If all you're going to do is just do a subtotal or something like that, then you can easily do that again using these little totals. It just creates a new line here that you can then, depending on the type of data element you have, kind of dictates what option is available to you as far as counts or sums or mins or max or average. Okay, but that's something that could potentially help you if you don't want to export to Excel as well. Alright, so I think that concludes my walkthrough here. Obviously it's not a thorough walkthrough of everything that you can do with Access, but it does at least give you a sense of some of the things you can do given some of the data you might have. Hopefully it helps you understand how to do joins, define relationships, those kind of things, which I think will be helpful for you. All right, hope this was helpful, and let me know if you have any questions. All right, thanks.